Today's laboratory activity will involve the Biodex Isokinetics muscle testing system. We've used this system for teaching basic muscle function concepts in our exercise physiology and exercise testing laboratories. We've used this to test some of our Coastal Carolina University athletes. They've also used that for rehabilitation. We use this machine to look at muscle imbalances, not only from right side of the body towards the left side of the body, but also opposing muscle groups within a limb. For example, quadriceps in the front of the thigh to the hamstrings in the back. And what we've found in the research has shown that when there are imbalances between those muscle groups, that leads to an increase in rate of anterior cruciate ligament tears, for example. So we can use this system to test not only knee strength, but many other muscle groups and limbs as well. All right, guys, we're going to do an isokinetic test on Zach. So the first thing we need to do is strap Zach down so that we can isolate the muscle groups that we're going to be testing, is quadriceps and hamstrings. So go ahead and bring the straps around over his shoulders and upper body. And we want those to be kind of snug. All right, now we're setting him up to test his left leg, but what are some other values of isokinetics testing? Why would we test the left leg versus the right leg in multiple muscle groups? What are some of the values of isokinetics testing?
See the difference between the two legs, if one's weaker than the other, if they've had an injury.
Right. If there's a muscle imbalance between one leg or the other with an injured limb, we really don't know how strong his limb was before the injury, so what we do is we compare the injured limb to his healthy limb. That way we have an idea of a starting point and how far we would want to go. And why would we want to test the strength of his quadriceps, muscles in front versus hamstrings in the back? What would a muscle imbalance on one side of the limb versus the other potentially do?
Can cause injury if there's an imbalance between the two of them.
Yeah, so for example, anterior cruciate ligament tears, one of the most common knee injuries that we see in athletics, are in many cases caused by a muscle imbalance between the quadriceps and the hamstring. So we're going to test both of those movements or both of those muscle groups at multiple speeds. So the first thing that we're going to do is set his range of motion. Let's hold it right there. Just hold it right about there. Another thing we're going to do is test you at multiple speeds. We're going to test you at very fast speeds and very slow speeds. And as we've talked about in class with the force-velocity relationship, if we're doing a muscle lift or a maneuver at a very slow speed, we would expect that your force production is going to be relatively high. As we increase the speed of the movement, there's less time to recruit motor units and muscle fibers into that action, so we would gradually see the force production drop off the faster the speed we go. So hopefully we can see that demonstrated on the screen here. And we're going to be starting out at a medium speed, probably about 60 degrees per second, somewhere in that range. Okay, so go ahead and take your leg all the way back and wait for the signal. Go. Pull back, kick, pull, kick, pull. Good job. Come on, Zach. Last one. Okay, just relax. I'm not sure if you guys could see the peaks or not, but quadriceps were probably about 30 to 40% stronger than hamstrings. Obviously, we know that there's 4 muscles in the quads versus 3 in the hamstrings muscle group. So that looked normal. Now the next speed we're going to do is going to be 120 degrees per second. So it's going to be twice as fast. So overall, what would his peak torque values be compared to 60 degrees per second? If we're doing it twice as fast. Yeah, it should be significantly lower, even though you're still giving your maximum effort. Okay, go. As hard as you can. Come on, Zach. Kick, pull, kick, pull. 2 more. Good. You're done. Relax. Now the next speed is going to be 30 degrees per second. So that's actually half the speed of the first one. So this is going to be very slow. This one is a little bit more strenuous, but we should see your peak torque values actually highest here of all. Okay, 2 seconds. Make sure your legs all the way back. Okay, go. Nice and slow. Good. Come on. Pull. Kick. Pull. Keep breathing. That's it. Don't hold your breath. Good job. Just a couple more. Good job. That's it. Relax. Last set. Go. Fast as you can. Come on. Come on. That's it. We're all done.